guys? I hope you're doing good today. And today we're moving on to Unit 6. Unit 6 is going to be dealing with circles. So we're going to be doing a lot of stuff with circles, and just so you know, some of the stuff that we learned in triangles will tie into some of this circle stuff as well. So we're going to be doing lesson 6.1, which we're going to be talking about something called inscribed angles. Okay, so let's jump into it. All right, guys, so the first thing we're going to look into is when we're starting the circle unit is we're going to go back and we're going to look at some definitions here. And then this is probably some definition stuff that you may have seen before, but we still kind of got to circle back and go back over it in order for you guys to understand what's going on. Okay, so the first one we're going to look at is something called the radius. And by definition, it says it is a line segment drawn from the center of a circle to any point on the circle and is half the length of the diameter of the circle. So I'm actually going to be talking about the radius and the diameter. So the first thing I'm going to draw here is I'm actually going to go ahead and draw your diameter. So over here, I'm going to actually draw a diameter. So whenever I draw my circle, it's going to go through the center of the circle, and I'm actually going to do this in a different color. It's going to be a line segment going through the center of the circle all the way across the circle. So the diameter is going all the way across the circle, okay? So now, by definition here, it says the radius is half the length of the diameter. So that means my radius over here, I'm going to draw my circle. There's my center. My radius is going to go from the center of the circle to the outside edge of the circle. And again, it's going to be 1/2 the measurement of your diameter, okay? And so just so you guys know, these are going to be line segments. So for instance, if this was point A and this was point B, this is point D and this is point E over here, your line segment here would be AB with a line above it. And then your radius here would be DE with a line above it. So again, just so you guys know, the radius is going to be 1/2 the measurement of your diameter. Okay, so that's going to come into play a lot here going through all this circle stuff. All right, so let's move on to the next one. So the next one, we're going to be learning about something called a chord. So a chord says it is a line segment that joins/intersects 2 points on a circle. Keyword, on the circle. So for instance, if I had a circle here, and then inside this circle, I had a line drawn here, and I'm actually going to use purple here. And inside this circle, so I have this point right here, I'm going to call it point C. And if I have this point right here, I'm going to call it point D. And I had a line joining those 2 points. This right here is going to be a chord. So again, line segment that joins 2 points on the circle. So I have point C, I have point D, that's creating a chord right there. It's going in between 2 points of a circle. And so if I wanted to write that, I'm just going to call it line segment CD with a line above it. So again, a chord connects 2 points on the circle. That, ladies and gentlemen, is a chord. The next thing we're going to talk about is going to be called an arc. So an arc is any smooth curve joining 2 points. The length of an arc is known as its arc length. Okay, so for instance, if I'm talking about an arc, the term put more arc on it, like if I'm throwing a baseball, put more arc on it, we're looking to make it more of a curve. Okay, so think arc is a curve. So if I'm going to draw a circle here, the whole thing around is going to be called an arc. So right now, if I was to draw, there's my center of my circle. And if I was to draw 3 points, I'm going to create 3 points on this circle. So I'm going to call this point A right here. I'm going to call this point B. I'm going to call this down here point C. So any measurement outside that circle connecting those 2 points is called an arc. So for instance, if I wanted to reference from point A all the way to point B, I wanted to reference that curve, this is how I'm going to write it. I'm going to write it AB with an arc above it. So right there, ladies and gentlemen, that is telling me arc AB, okay? So for instance, if I wanted to call arc AC, so I wanted to go from here to here, I would then say this is arc AC. So those are going to be any 2 points going in between those. So if I just write 2 points, I'm always going to pick the distance closest in between those. So now if I wanted to go all the way around, let's say I wanted to say A all the way to C going this far all the way around here, I then have to use 3 points to call that arc. Because if I just write 2 points, I'm going to go the closest distance between those. So if I wanted to go the farthest distance around, I'm going to use a different color here. I'm going to use purple. I would have to say arc A, B, C. So then I'm going to follow that arc. So I have to go from A all the way to B, all the way to C. So again, if I want to go all the way around the circle, I have to use 3 or more so I can make sure I go all the way around. If I just use 2, it's going to go the shortest distance around those. Okay? All right, and then lastly, we're going to learn something called the central angle. The key word here is central, okay? So when I'm talking about the central angle, this is what it's saying. An angle whose vertex is the center of the circle and whose sides are the radii of the circle. So for instance, if I'm going to end up drawing this, I'm going to have a circle here. And then I have a center of my circle here, correct? So whenever I draw an angle, I'm going to have 2 radii creating this angle of my circle. So that means this angle includes the center of the circle. So when I draw this, let's say this is point C, this is now going to be my central angle because it's including the center of the circle. So let's go ahead and say this was A and this was point B here. So that means angle ACB is going to be my central angle. And let's go ahead and say this central angle is 60 degrees. So with that being said, I would then say angle ACB is going to be 60 degrees because that's my central angle. And so now just so you guys know, any central angle, its inscribed arc up top, this intercepted arc is going to be the same measure. So for instance, if you look, this angle opens up to A and this angle opens up to B. If the angle is 60 degrees, that means the measurement of arc AB is also going to be 60 degrees. So the intercepted arc is the same measure. So if this is 60 degrees, the arc is also going to be 60 degrees. Those match up, okay? All right, and the last thing we're going to look at is something called an inscribed angle. So inscribed means inside of the circle. It's inscribed in there. So an inscribed angle is an angle whose vertex is on the circle and whose sides are chords of that circle. So if I have a circle here, and let's say this is point A right here, let's say this is point B right here, and let's say over here this is point C. And I was to draw lines that are connecting these. So if I drew a line from A to B here, and I drew a line from C to B here. Right now, angle whose vertex is on the circle, right here my vertex is on the circle, and whose sides are chords of that circle. So from B to C, those are points being joined by a line segment inside the circle, chord. From B to A, points on the circle and a segment joining those, that is also a chord. So right now, ladies and gentlemen, this is an inscribed angle, okay? And so right now, if I'm going to talk about an inscribed angle, there's a special way I can actually find this angle. So right now, the measure of angle ABC is going to be equal to 1/2 of the intercepted arc. So right now in this instance, my intercepted arc is going to be arc AC. So I'm going to take 1/2 of AC, arc AC, okay? So just for example, let's go ahead and say this angle was 70 degrees. So in this instance, if I wanted to find the measure of ABC, I'm going to take 1/2 of 70 degrees. So 1/2 of 70 degrees is going to equal 35 degrees. So that means in this instance, if this was 70 degrees, this is going to be 35 degrees. So ladies and gentlemen, that's an inscribed angle, and that's actually how you would end up finding it, by taking 1/2 of its intercepted arc, okay? So we're going to take these definitions, we're going to take these terms, and we're going to look down and we're going to apply it to our examples down here, okay? Okay, so let's jump to it. All right, so look at example number 1 here. So right now we have a circle, and it says we need to find the value of A, B, and C in this instance. Okay, so right now there's not some special way that we can go ahead and start out with this, but I'm just going to start somewhere here. Okay, so right now let's go ahead and look. Let's go and look at angle C, and I'm going to use a different color here so we can see it. So right now, if we look at angle C here, it is being made up by this point right here. We have a chord going here, and we have a chord going all the way over here. So right now, ladies and gentlemen, this looks like an inscribed angle. So by definition, an inscribed angle, we have to take 1/2 of its intercepted arc. So it looks like this line's going all the way over here to this point. This line's going all the way over here to this point. So that means from here all the way to here is going to be the intercepted arc. So that means in order for me to find angle C, so angle C is going to equal, I'm going to take 1/2 the measure of 122, because this is its intercepted arc. So right now, angle C, if I take 1/2 of 122, is going to be 61 degrees. Okay? So now let's go and look at angle B. So I'm going to use a different color here. So right now, angle B right now, there's the vertex. It has a chord going down this way and a chord going down this way. So it looks like I have another intercepted or inscribed angle. So right now, if we look, its endpoint is right here. Its endpoint is right here. And it looks like this angle right here, or this arc right here, is going to be my inscribed arc, or my intercepted arc right there. So right now, if I look, this is the diameter. So the diameter is 180 degrees. It's a flat line. So that means this is going to be 180 degrees down here is my arc. So right now, in order for me to find angle B, I'm going to take 1/2 of its intercepted arc, which is 180 degrees. Okay? So 1/2 of 80 is actually going to be equal to 90 degrees. So that means angle B is equal to 90 degrees. So angle B is 90, angle C is 61. And now if we look, what do I know about all 3 angles of a triangle? All 3 angles of a triangle add up to 180 degrees. So that means 90 plus 61 is going to be 151. Subtract that from 180, and this angle down here is going to be 29. Okay? But now let's go ahead and look on how to find A. So it looks like angle A here is going to be an arc length here. We see the arc? And that arc is being created by this chord and this chord. Well, I know a while ago, I took 1/2 of the measure to get my angle, correct? So then to go backwards, I would actually have to multiply by 2 to get my arc. So that means right now, this angle right now, 29, is going to be equal to 1/2 the measurement of arc A, correct? So that means in order to get A by itself, I have to multiply times 2 on both sides, correct? So that means A is going to be equal to 58 degrees. So that's going to be my angle. And real quick, I just want to go ahead and show you guys something. So if I took all the measurements of all of these here, they're going to add up to 360. So that means 122, 180, and 58 are all going to add up to 360 degrees. Well, let's think about it. All of my inscribed angles that I just drew here form a triangle. All the angles of a triangle add up to 180 degrees. So that means all the angles of a triangle add up to 180. So look, full circle. This is my inscribed angles. That's 1/2 the measure of my full circle. And that's how I end up finding each one of these angles, by taking 1/2 of that arc. 1/2. So that, ladies and gentlemen, explains and proves that all I have to do is take 1/2 of that arc to get the angle. Okay, so let's jump over to example number 2. All right, so now in example number 2, I want you to find the value of x and the measure of arc MN and MNP. So right now, the easy one here is to find my arc MN. So right now, arc MN is going to be equal to, if I look, my central angle is 50 degrees. So that means my central angle and my arc are the same measurement. So it'd be 50 degrees. Right here, this is 90 degrees. So that means this arc right here is also going to be 90 degrees. So from MN, it's going to be 50 degrees. And then now it wants me to find the arc of MNP. So MNP arc is going to be equal to 50 plus 90, which is going to equal 140 degrees, okay? So now if I look from here all the way to here is going to equal 140. So that means from here to here is going to be the rest of my circle, which is actually my central angle, okay? I know the full circle is going to be 360 degrees. So to find this arc here, I'm actually going to take 360 and I'm going to subtract 140, which when I subtract those two is going to actually give me 220 degrees. So that means from M all the way to P over here is going to be 220 degrees. So now if I look, my central angle is also the same measurement as its arc. So that means X is going to equal 220 degrees. So X is going to be 220 degrees. So ladies and gentlemen, that's how I take all these definitions that I just learned and we apply them to some examples to kind of combine everything and use everything together here. So good luck on your skill check and please let me know if you have any questions.